Welcome back. This is part 3 of the Calc 1 Exam 3 review. Here we'll be finishing up the review by taking a look at question 5. And, I was about to say question 6, but question 5 just has 5 parts. It's fine. So we're told that a function represents, let's zoom in, the horizontal velocity of a golf ball t seconds after it was struck. Oh my goodness, I'm struggling. T seconds after it was struck. Then we're looking at a definite integral, right? Approximated by the right endpoint approximation with in terms, blah, blah. We've looked at this. I make a little note that this Riemann sum is based on a uniform partition. That just means that all the widths are the same. What it wants us to do is explain what the following pieces of this expression are on the context of the situation. Well, first, let's try to kind of work backwards. What does this mean? What does the whole integral mean? Well, if we're taking a velocity, the integration of velocity will be a distance traveled. So the integral from A to B of a velocity will be how far the ball has traveled between time A and time B. Okay? So all of this, it has a physical meaning to it. Okay, so let's look at delta t. What that means, that's the amount of time that passes between each velocity sample. How do I know? Well, I'm going to just sketch graph. Let's say the velocity looks something like that. It definitely doesn't. And we're integrating from A to B, or summing from A to B here. This axis is time. This axis is f of t. If I knew the whole equation for this, I would probably just integrate it. But let's say I only have a few points to know at, right? So I have to take a sample as I'm watching the ball. And each sample, there's some amount of time in between. And that's actually going to be the width of these rectangles that we're using in the sum. And the width of those rectangles is the time between the samples. What will A plus K delta T represent? Well, K is just a counter, right? The point of it is that at different Ks, I get to different times. So what this is the time of each sample. I'm using the word sample. You could also use point. That works too. What will f of a plus delta kt mean? Well, if this is a time, if this is a t, what is f of t? That's the velocity of a ball at each time. I say a ball, but the ball. Okay. Yeah, not so much more I need to say here. I'm going to move on to the next page. Okay, so we said that f of a plus k delta t, oops, why am I rewriting it, was a velocity. And delta t was a time. But it was a time of what? It's just a small amount of time. sample time slash small amount of time. What happens when you multiply velocity by time? You get distance. So what this will represent is the distance the ball travels between I've been saying samples, between points is another way to think about it. So what happens if we sum up all of the distances between our samples, between our points? Well, we get the entire distance the ball has traveled, right? So the distance the ball travels between time A and time B. It's important to note that this is an approximation. And that what we really should have said in part D, this isn't the distance the ball travels between samples. It's not exactly that. It's the distance that it would travel if the ball had constant speed from or between rectangles. What does that do? Well, rectangles are flat on top, right? So that means whenever we're using a rectangle, we're saying, okay, we're going to act like the velocity isn't changing during the width of this rectangle. But it does change, so we make another rectangle later on that's a little bit higher. It's just what we do. So this is an approximation. So what happens if we take the limit as n approaches infinity? If we take infinitely many samples? Well, we don't have to approximate. This is the true total distance the ball travels. I should say this is an approximation using in samples. It's how many points we use. Well, n plus one sample. Not a big deal. The total distance the ball travels between time A and time B. Okay, well, that is actually the completion of this exam review. If you have any more questions, hit us up at the MLSC. We're much better at responding to questions than just filling out exam reviews like this blatantly. Good luck on the exam. I hope this helped. And, well, you guys are awesome. You'll rock it. Go Pokes.